All right, today we're going to talk about 8.4 lengths of a curve. So in this section, what we're trying to do is we're going to take a curve and we're going to try to find the length of that curve. So if you look at example number 1, it says, what is the length of a curve where y is equal to sine x from 0 to 2 pi? In other words, so if I have 0, this is y is equal to sine x, right? So y is equal to sine x. I'm going from 0 to 2 pi. Okay, 0 to 2 pi. I want to know what the length of this curve is. Okay, all right. So this is example 1. Okay, so we're going to go straight into page. If you look at the actual equation on page 421, it gives you a definition on the bottom of the green box there. It says arc length, length of a smooth curve. Okay. And it tells you that the arc length, the length of the curve is from A to B. It's going to be, what, root of 1 plus dy dx squared dx. Okay? That's nothing more than that. Okay, and the bottom one, it's going to give you L, the length is A, or I should call it, since it's different A, we're going to go different, we're going to go C to D, 1 plus dx dy squared, and you can do it about dy here, okay? So let's go back to this one. Just go ahead and plug and chug into this guy right here. So I'm going to get the length is going to be equal to from 0 to 2 pi square root of 1 plus dy dx. This is the y. So dy dx would have been cosine squared, right? X dx. Because I have to square it over here, right? Just square it. Okay. So if I do that, what do I get? How am I going to do this? You're going to actually have to just nint this, right? You're going to have to nint this, okay? Because I have this x squared in here. I don't know what to do with it, all right? So we're going to have what? If we nint this, this ends up being 7.64. 7.64. There you go. That's it. We have calculated the length of the curve from here to here. Okay? So let's see. You can notice that it says the arc length of a smooth curve. So you would consider this to be a smooth curve, right? There are no cusps or no points or anything like that, right? Okay, let's go to example number 2 and see if we can do the same thing. We're going to use the same definition here. All right, so let's do example number 2. Example number 2. Example number 2, we're going to do find the exact length of the curve. Y is equal to that mess for x equal to 0 to 1. So y is equal to 4 root 2 over 3x to the, what, 2/3, 3 halves minus 1. And I'm going from x equal to 0 to 1. So what I'm going to do, I'm going to go length is, so I'm going to use the top one or the bottom, right? I want to use the top one because I have y is expressed into x. But not only that, I'm giving the boundary here from x is 0 to 1, right? So I'm going to go 0 to 1, 1 plus, I'm going to take the derivative of this. When I take the derivative, what do I get? I get y prime is equal to what? 3, 2, 3, whoops, not 3. This was 4 root 2 over 3, x and 1/2, right? This goes away, this becomes 2, so I'm going to get 2 root 2, x to the 1/2, right? So I'm going to square that, 2 root 2, this is dy dx, right? dy dx, x to the 1/2, I'm going to square this. and go from 0 to 1. So I'm going to go from 0 to 1. 1 plus, so if I square this, I get 4 times 2 is 8 x dx, right? Okay. So how do I do this? This would be, what? This would be, this is basically 1/2, so it would be 3 over 2, 1 plus 8x, 3 over 2. Then I have to divide it by 8 because of the chain rule, right? Because of the chain rule, and I go from 0 to 1 here, right? So I put 1 in here, so I get, what? This is 4, so I get 1/12 here. If I put 1 in here, I get what? That'll be 9. So the root of 9 is 3. 3 to 3 is 27. So I'm going to get, if I divide by 3, I get 9 over 4. Okay? And, oh, what did I do wrong here? 0 to 1, 3 halves, 4, 1/12, divided by 3, 9. 2, 2, 2, 2. 26? Where's the 26? Where do I get 26 here? Okay. This seems to be the correct answer. So I don't know what's going on with the book there. All right, so let's go ahead and do example number 3. Example number 3. Well, let me go ahead and look at this one more time. 9. Yep. Oh, I have to subtract the 1. Never mind. So when I put 1 in, I get this. So the 12 stays here. I put 1 in here, right? And then I have to subtract the 0 when I put the 0 in. And the 0 when I put the 0 in is what? 1 to the 2/3, so it's going to be 1. So we're going to get 26 over 12, which is 6 over 13. There we go. Okay. And mystery solved. Okay, so let's do example number 3. I'll erase this now. Example number 3 shows you an example where you do not get a smooth curve. You get what looks like a smooth curve, but actually it's going to cause you some problems. Okay? So example number 3, we have y is equal to cube root x, and we're going from -8 to from here to here. Okay? Notice it didn't give you this, it gave you the 2 points, actually, right? Okay, so that's kind of a little hint there, all right? So if I graph this, what am I going to get? I'm going to get something that looks like, I'm going to graph, it's going to, oops. I'm going to graph it, it's going to look something like this, okay? And the problem occurs right here. At here, what is my tangent line going to look like? I'm going to actually get to a point where the tangent line is going to be infinity, right? So this is where if I go ahead and put this in, and I just do a straight thing and I do the nint, my calculator barfs on it because it doesn't know what to do at that point. So here what we're going to do is, so this was the x and the y, we're going to go ahead and rewrite this to x is equal to y cubed. And we're actually going to draw it like this, and we're actually, if you look at page, where is it, 422, the left-hand side, figure 8.41, okay, you're going to see something you'll almost never see again. You're going to see that this is the y-axis, and this is the x-axis when they went ahead and drew this up. And the reason why we do this is because now I have the stuff in here is now going horizontal. It's not going vertical anymore. And I can handle the horizontal part, okay? So I'm going to redraw this. So to make it kind of, let me go ahead and emphasize. There you go. So this part here, what was here now, is now a horizontal part, and I can handle that. Okay? So what we're going to do is we're going to have L is, we're going to go from, and we're going to go what? So this would be dy, right? dy. So I'm going to end with dy here, which means that I want to use the 1 plus dx over dy part. So dx over dy is going to be what? So dx dy here is going to be 3y squared, right? So I'm going to have 3y squared here. I'm going to go from where to where? Y is going to go from -2 to 2, -2 to 2. Okay? So this is what I need to do. All right? And then you can go ahead and nint it from there. All right? And if you nint it, you're going to get what? You're going to get 17.26. Okay? So that's how that works. Example number 4. Example number 4, I'm not going to actually go into it, but if you look at the graph, what do you have? Do you have a smooth curve there? You do not have a smooth curve, but you have a combination or addition of two smooth curves, right? So the smooth curve is from -infinity to 0, and from 0 to -infinity. So in here it's going to be what? From -4 to 4, right? So -4 to 0 is a smooth part. And then from 0 to 4 is a smooth part. You just add those two smooth parts together, okay? And that would have been example number 4. All right, we're done.